All right. Hello, everybody that is joining us. I'm going to give everybody about one more minute and we will get started with our League of Railway Women webinar. Okay, here we go. Well, welcome this afternoon, morning, wherever you're at, to our another technical series of our League of Railway Women webinars. As you may know, the League of Railway Women is a professional organization that was actually founded in 1997. We are dedicated to connecting and cultivating women in rail. Membership is open to anyone who is affiliated with an organization that shares this goal. And we've really been focusing our programs on improving the representation of females in our industry and providing growth opportunities to better diversify our industry. I wanted to go through maybe if I could slide my show, there we go. Needed a little bit of time to catch up. I wanted to go through a few webinar housekeeping items. Well, I guess first I should introduce myself. I am Carrie Gonzalez. I am currently the Vice President of Business and CFO at the Transportation Technology Center, and I am the chair of our Education Committee at League of Railway Women. You are all right now joining in a webinar, and so you have two ways to listen in. Number one, your computer's audio system should work just fine. If you prefer to have a telephone dial-in, please use the audio pane and dial-in information will be displayed there. You can submit your questions via the questions pane on the control panel, but you will be on mute for the entirety of the presentation. At the conclusion of the presentation, we will be going through any of the questions that we have. If there's some that we don't get to due to time limitations, we will pass those on to our presenters and get those out via our website. This actually, I didn't update that bullet. This webinar will actually be recorded, so any members will be able to access this particular webinar through the portal on the education on the members only side of our webpage. Which brings me to our ability to become a member. We have individual memberships and corporate partnerships. We have seen a very, very big growth on the corporate partnership side because there are a lot of great opportunities through that program. This is just a high level to show you the different ranges in which your company may participate. If you don't have a company that is interested in the corporate partnership, again, you can join as an individual at $60 a year. Definitely go to our website under the membership tab and take a look at what's offered for each the individual and the corporate partnership ranges. Lots of good things and more things to come with our mentor program kicking off, and also looking at a few different job board possibilities. So also contact information for all of our chairs is available on our website. So if you have any questions, please feel free to reach out to any of us. Just a quick overview, and I'm not going to go through all of these because you can see there's a lot, but we always like to stop and say thank you to our corporate partners. Their participation in our programs really helps us to put on great events and provide more education to all of our members and non-members that are on the phone today. So without further ado, we are going to move on to our program. This is our third or seventh session in our Railroad 101 segments. These are really focused on the technical aspects, but in a more consumable format for the entirety of our membership and non-members that are joining us today. I am fortunate enough to be able to introduce two great individuals. We have S.A. Ikurebe. I hope I did that right. Essie is an emerging leader in our industry who is currently working for Hatch on the rail systems design team. She holds a bachelor's of electrical engineering with honors from the University of Waterloo. She's been in the industry for about 5 years, but has gained a large amount of experience working on a variety of projects for Metrolinx, Canadian Pacific, and other rail-based firms. During her time with Metrolink, she actually managed the analysis and reporting on the Geo Railway corridor performance, which supports equipment integrity investigations and coordinating maintenance activities of signal assets. Since joining Hatch in 2017, she has excelled as a signals designer, producing designs from crossing infrastructure upgrades from railway-based systems and grade crossings. Her interest in grade crossings has really led her to involvement with a lot of the work with CP, looking at methods and benefits of drone technology. So that's kind of a cool aspect of her background, because there's not a lot of us that get to play with the new technology. So bravo. You're going to see through this webinar that she has a passion for learning and sharing that knowledge with all of us, which we're so excited about. But in her personal life, she also likes to volunteer as a videographer for CTF Toronto. So I think you have that little bit of artistic flair that you're bringing your engineering expertise to. Our other presenter is David Smith, who is the Regional Director for Rail Systems for Heavy Rail at Hatch. David brings a wealth of experience, wayside signaling and crossing warning systems, which in his career spans over 3 decades, with extensive experience in North American rail and transit industry. So we have 2 sides of the spectrum today, somebody that's coming in and somebody that knows a lot. So I hope we're going to get good variety there. Dave also is an active participant in ARIMA Technical Committee 36, which is the Highway Rail Grade Crossing Warning Systems, and Technical Committee 39, which is the Positive Train Control. Dave, good luck with that one. That's a big, heavy lift and probably a lot of exciting things going on there. When Dave's not at his day job, he is an active contributor in the community. We were just speaking a little bit about all of the volunteer efforts that he has on the baseball and softball side. It's near and dear to our hearts. So without further ado, I say I'm going to hand it over to you if I can do this effectively, and we're going to get going.
Okay.
All right, we can hear you, we can see you. I think you're ready to go.
Okay, awesome. Sounds good. Good day, everyone. It is my pleasure to be presenting on the topic Introduction to Engineering Design, specifically looking at railway applications as the overarching theme. The intent of this presentation is not meant to be predominantly technical. My aim is to provide just a high-level overview to familiarize us with what engineering design is, why it's important, and what the engineering design process can look like within the railway industry. So a brief look at the outline for today. I will kick us off with a safety share. Safety is such a huge part to what we do. One of the things that we do strive for within our various organizations, wherever we work, is to achieve no harm. And so I think it's really important that we kind of start off on the safety note. After that, I will get right into it, looking at engineering design, defining it, what the process is as well, and what that looks like, why it's important. Then I'll switch gears into the railway applications in terms of what we have as examples for applications. And then I'll cover the engineering project lifecycle overview, just giving us a sense of what the lifecycle can look like for an engineering project. And I have a project example that I'll use to tie all the concepts together. One thing I do want to state is there is a lens of perspective with which I'll be presenting on the topic. And so that will kind of unfold as we go, because this is such a vast subject and there's so much that I could say about it. But I'll only be speaking from a specific perspective today. So when was the last time you took a deep breath? Now, the safety topic for today is the art of breathing. Now, in this past year, we've been through such a difficult time, and it's prevented us from doing the things that we love and spending time with the people that we care about. And some of us have experienced loss in the ways that we haven't anticipated or imagined. And the stress levels that we've been going through has been really, really intense and difficult. And so one of the ways with which we can ground ourselves or just be aware or mindful of where we are is through breathing. And so I thought that it was important to shed a bit of light on the topic of deep breathing. There's so many ways with which we can breathe, but one of the methods that I picked today is squared breathing. And essentially, how it's performed is we inhale for a count of 4, hold our breath for a count of 4, exhale for a count of 4, and hold for a count of 4. And so before we carry along into the technical side of this presentation, I think it's important that we practice this, and I'm going to play a video on the next slide and have everyone do with me. You know, I can't see everyone's reaction or what their where everyone's at, but regardless of the day that you have, whether you've been on a high note, everything's going well on a low note, I think it's important that we both practice this together. So at the count of 4, I'm going to play the video. So I encourage everyone to, wherever you are, sit up, relax your shoulders, try and stay present and be present in this moment. And so I will play the video now. Just gonna cue that up. So by the time I count down to 4, we're gonna start off with the inhale. And so we'll inhale for 4 seconds. We'll hold our breath for 4 seconds, then exhale for 4 seconds and hold for 4 seconds. So I'll go 2 rounds, 2 cycles of this. And there's gonna be a visual cue. I don't know if you're gonna be able to hear the sound, but there will be a visual cue that lets you know what cycle we're in. So counting down now, 4, 3, 2, 1. And we hold. Awesome. So hopefully everyone's feeling a little bit relieved. I know I am. So what are the benefits? Oh, I went too fast. This is where I want to be. Awesome. So the advantages of breathing, it does help reduce stress levels and increases calm, increases our energy. There's scientific articles on the results in terms of lowering heart rate and blood pressure. And a big part of it is being able to regulate the body's reaction to symptoms of trauma, such as anxiety, worry. Over given the pandemic that we've been in, there's a way that our lives have changed, and we don't even realize with the way with which the news we're receiving and all that is affecting us. And so I really encourage everyone to take some time within the day to just, practice deep breathing, whichever way you choose to breathe. Just make sure that you're taking just a minute within the day or 2 or 3 or more to just be aware of how you feel, where you're at, and feel better. So engineering design and the design process. So what is it and why is it important? And those are 2 questions I'll be answering in this section. Now, the engineering design is interwoven into the fabric of our society. It is one of the instrumental factors that influences how our world evolves. Now, one of the definitions that I did really think was keen to use was this: the plan or drawing produced by engineers to show the function, workings to construct and maintain a product or system that solves a problem and fulfills a need. I know it's a little bit wordy, but to just break that down, essentially is the means through which engineers illustrate the solutions to the problems or challenges that they are trying to solve. Now, engineering design often has the goal of optimizing efficiency, reducing costs, enhancing a system or product to ensure that in whatever constraints or parameters that we have, we are able to provide the best solution for that problem. The engineering design process is defined as a series of procedures that engineers follow to produce a solution to a problem. Essentially is the way that we get to the outcome of our solution. So all the methodologies and everything that is intricate to that portion of it is pretty much what the process is. So the engineering design process. Now this diagram that I have here is just it's more of a generic illustration of what the sequence is. And engineers may not always follow this steps in the exact order because it could differ. So you can see on the left hand of my screen, I have the client, consultant, contractor, vendor. And one of the things I wanted to do to kind of explain the different tiers that I do have there is, depending on what the project is, we could have different roles within that, and everyone relates to the design process differently. So for example, if we consider a design bid build project that has a client who needs a problem solved, and so they outsource that design to the engineering consultant that is responsible for the design of the solution. You also have a contractor, which they can outsource that to be responsible for the building, testing, and commissioning of that solution. And then a vendor who is responsible for manufacturing and supplying the parts that are used for that solution. So what can the process look like for the different parties involved? So in the case of the client, they could specify the problem to us and let us know, this is what the problem is, and they could present us with a few different options and what they think might solve the problems. Typically, clients have their certain requirements, constraint standards that they would typically have in terms of what they want the engineering design to follow. On the consultant end, specifically engineering consultant, the party responsible for the design, they are involved in all the specific parts of the process. And so typically, based off of the solutions that they provided, they could assess those solutions, brainstorm possible solutions that could solve that problem, research ideas. That's a really key part in engineering, being able to research and kind of know what is possible, being able to assess that, bouncing off colleagues to be able to determine what the possibilities are for the problem that we're trying to solve. And then we typically confirm the requirements in terms of, okay, what are the requirements that we're trying to satisfy to solve this problem, and give the client the solutions that they're looking for. And then after having assessed all the different requirements that we have, then we begin to evaluate the solutions and weigh them in terms of like the pros and cons and the possibilities given the constraints that we've been given to design that, to solve that problem. And then having done that, then we select the best solution, and then we develop the design. A key part of the development of design is also the quality control within it, and being able to make sure that we're going through the proper iterative processes to make sure that we are satisfying the constraints of our scopes, as well as solving the problems that we need to. And then we typically build a model or prototype. Now, for the engineering consultant, depending on the model or prototype could look different. It could be software where we simulate the solution that we've created, and then so we run it through a test and evaluate to see that we're meeting the solutions, we're satisfying all the requirements that we need to. And then if anything that if there's anything that we see within the test and evaluation process, we can then refine the design to ensure that, okay, whatever thing seems a little bit out of place, we could correct it. And then after that, the solution is typically finalized. It's interesting sometimes though, because sometimes it doesn't necessarily always follow this sequence. It could really vary in terms of the way it shows up. And lastly, we'll typically communicate the results in terms of the drawings that we create, reports, memos, or presentations that could follow. On the contractor end, in the event that the contractor is doing the actual build of the solution, then they will be the ones responsible for building the models, testing and evaluating the actual solution on the site wherever that's going to be built, redefine the design, outlining the solution based off of what they've seen as a problem from their tests, as well as communicating the results back to all the stakeholders involved. One of the reasons why I have all the processes included here for the vendor is sometimes the vendor is just a supplier and in terms of delivering the actual product, but sometimes the vendor is also the person that manufactures it. And so if the vendor, looking at the vendor as the manufacturer, then they do have to be able to go through all the processes involved, all the steps in the engineering design process, because typically they would be given a specific product that meets a technical need. And so sometimes, and in most cases, the manufacturers do have to follow the same design process that we would have, and it will look, it's pretty much similar to what we have on the consultant end, just the deliverables are different. And so why is the engineering design process important? Well, three things that it does help do is it helps improve the quality of the design, help us produce designs efficiently, and helps us accurately meet the requirements, because the structure allows for us to be able to have an iterative process that helps us check our work, to know what we've done, to see that we're confident, to check it against as well the client requirements and scope, to see that we're meeting those needs. And because of the process, we are able to streamline and make things more efficient. The cost for the engineering design process consists of resources in time and material. There is so much that's put into play in regards to what we have to do for the designs, in regards to people, expertise, factoring the materials, the actual items that we're going to use for the build, to make sure that we are that those materials satisfy what we need them to do. Being able to manage those resources is a huge part of the design process, and that's what it typically entails. Engineering design and railway applications. Now, the next section on this slide, I'll be diving into the process of looking at the railway a little bit more specifically, just highlighting some project examples and the life cycle of the project and what that can entail. Engineering design is important to sustain and advance the industry, and we do this by building or designing for new infrastructure, as well as upgrading the existing infrastructures that we do have. Now on this slide, I'm going to be illustrating an example that kind of highlights how like a bigger infrastructure project for grade separation, which is a project involving pretty much splitting the roadways from the railway, and we can get to see an example of an actual site build and how it went. So the video we just saw, there are so many engineering disciplines that come together to make a project like that happen. And on the slide right now, these are examples of some of those disciplines. This is not an exhaustive list. We have the electrical, civil, track, signals, mechanical, safety assurance, communications, environmental system integration, and integrating all these disciplines and making a project successful requires a lot of expertise and a lot of resources to make it happen. And this is just to highlight the different disciplines that we can have within the industry. So for the engineering project lifecycle, we typically have conceptualization and feasibility, preliminary engineering, detailed design, execution and construction, testing and commissioning, and safety certification. To get a little bit more specific, I'll be using a project example. Project Alpha is what I'm going to call it. And for this project, we had to add a crossover and upgrade two crossings. And it was a project involving about 2 miles. It was about 2 miles of track. And sorry, give me a second, everyone. My throat is getting a bit dry. Okay. Conceptualization and feasibility. Two questions that are important in this is asking what problem are we trying to solve and what is the solution to the problem. And so in this case, for our clients, they had high volumes of commuter traffic, and with commuter traffic increasing, there was a need to be able to expand the service of what they were having within the railway corridor. And so one of the ways with which that they decided to solve that problem was increase the train speed and service frequency, as well as upgrade the existing infrastructure to be able to meet this need that they had in regards to the commuter traffic. And so what are some of the other things that we looked at in regards to, I guess, the conceptualization and feasibility was on the design side, we had a risk analysis, we had site inspections, we had surveys, we had crossing assessments, and these were all the things that we had to do in regards to making sure that we could get our data. So typically for a site inspection, we would go to the site, take pictures, whatever measurements that we need. We would typically also draft whatever questions or assumptions, things that seem a little bit unclear. And one of the good things about or important aspects of the conceptualization and feasibility side is because this is the time where we need to pretty much figure out, okay, what are the inputs of what we're looking for, and what is the state of the existing infrastructure, and what is our assessment of what is and what do we need to do. The preliminary engineering design, one of the major things that it does is it frames the scope of what will be done to solve the problem. And so the design considerations that we typically have to factor in are the client requirements, the constraints that we've been given, whatever assumptions that need to be made, as well as the standards. Now, some of the standards that I had used specifically for this project in reference was the ARIMA. For the crossings, we typically would refer to the Transport Canada grade crossings, as well as whatever client standards that we do have. And essentially what we were doing in this stage was pretty much looking exactly at what we needed to meet in regards to, so for example, one of the things for the crossings, one of the things that's important is regards to the type of system that we're going to install based off the requirements. The gate delay is huge. Being able to determine how much of a gate delay we need before we can activate a crossing, before we can have the cars come across the railway track. So that's something that we would typically check. In regards to the detailed design, there are two main aspects of it. There is the issue for review that we'll typically submit, as well as the issue for construction drawings. Typically for the issue for review drawings, we would, in this case, I think we had about one review stage. And so typically what happens is we'll have the designs created and issue that to the client to review. And for the construction drawings, these are the drawings that are actually going to be built. This is an example of one of the sheets from our signal drawings, and essentially it's showing the crossing, one of the crossings in the middle, and the crossovers as well on the side. I don't know if my mouse is shown right now. And the key components to the detailed design drawings are typically the legend, which pretty much defines what the symbols on the drawings mean, as well as the notes. And so we typically would show, and so essentially this pretty much illustrates what we would have for the signals. And so some of the other things that we do have as main items are like our signal housing equipment. It shows the cables, it illustrates the crossing warning protection system as well. For the civil drawings are different as well from the signals. This is the drawing list as well as the legend that pretty much defines all the things that are going to be within the civil drawings. This is an illustration of what our civil drawings were in terms of the alignment and what the crossover is, which is what's shown in the middle. I guess the black symbol there within the middle. This is an example of what our electrical drawings were that were submitted as well for this project. Just to give us an idea of what they looked like. We had shown the power distribution panels that were supplying the equipment. The second to last part of the project cycle was the execution, testing, and commissioning. Typically, when the design's done, we have to test it. We have to, I guess, build, test, and make sure that everything works according to how we want it. Coordination is such a huge part to making a project successful. We have the different stakeholders that we have to consistently be in touch with, the clients, the contractors, the consultants, coordinating to make sure that everything goes according to plan. We would typically have the schedule based off of those coordination meetings, have the schedule aligned accordingly, there'll be a factory acceptance testing done as well in regards to the signal equipment or whatever equipment that was built. We had the installation phase after the factory acceptance test in regards to the on-site work. System acceptance testing pretty much ensures that everything is, the system is working as it should be. For the main commissioning, what we had was a long weekend of a main commissioning weekend where we ensured that we're able to close off we're able to disconnect the existing equipment and tie in the new for the upgrades and make sure that everything was working as they should be. The final stage of the safety certificate, the final stage is the safety certification stage. Typically for this, we had like the project walkthrough, so working through the site to make sure that everything is as it should be. There's typically an in-service certificate that is signed by the engineering consultant, the client as well as the contractor doing the build and testing to make sure that everything is built as it should be. And then the last but not least is the as-built and record drawings. This is such a huge part to documentation, to making sure that we have all the drawings and all the designs updated to match the actual site work that is being done. A key takeaway for the design process is the importance of understanding the requirements, knowing what the problem it is that we're trying to solve, and essentially all the parameters that ensure that we are designing and meeting the solutions that we need to create. Verifying and confirming is a huge part of the design process because there's so much information that a designer gets, and we have to ensure that technically in regards to the source of that information that they are correct to the industry standards that we have. Communication is huge because with all the players that we have involved, it's important that we're communicating to making sure that everyone understands the different parts that they need to play within the project to see that it's successful. And that ties into integration, which is a big part of tying everything together in regards to making sure that the project is successful. And that's about it for the design process.
Wonderful. Well, thank you so much for taking that or taking us through that. I do have a few questions, and you can decide if you want to take them or if you want to put a little pressure on Dave there.
Yes, I think we'll do that.
One of the questions that has come up is in regard to the makeup of teams and how you work with different types of professions within these larger programs. So can you talk a little bit about the types of other skill sets and people that you're working with in these throughout this process, and how you may handle, and approach one situation versus the next?
Well, that's a loaded question. And Dave, feel free to chime in if you need to. So typically, I'll use Kitchen as an example. The Project Alpha as an example. I was on the signals design team. We had a civil/track design team as well. There was an electrical design team, and I believe we had the utilities as well. So typically, I interfaced with the electrical and the civil design groups. And so in regards to the teams, for our team, we typically would have a designer who is responsible for doing the first level designs. And then we have two other stages where we have like a checker, and then we have like our engineer of record. And that's the person responsible typically for sealing the drawings and ensuring that the drawings are to standards. And so in regards to how we interface for that is, as a rep, we typically have our coordination meetings between the different reps for the different groups. And so typically there is that conversation happening in regards to the different teams providing updates as to what they're responsible for. Typically, we would one of the reasons why it's important to rely on the expert is because as a signals designer, I may not be able to interpret the other engineering disciplines and what their designs translate to always. And so it's important to have those experts. And so those type of design meetings or having those collaboration points help us have those conversations to ensure that we're all kind of aligning to the task. And so I guess to summarize, each different discipline has its own sub-team that is responsible for the technical specifics of that discipline. And then there are typically core reps that integrate or have the bigger conversations to making sure that everybody's aligned to the same scope.
Perfect. And I'm sure that's a huge challenge as the projects get bigger and bigger. The next question that we have is asking about what do you find is left out of the project management slash planning process most often?
That's a good question. Dave, do you want to take that one?
Yeah, that's a really interesting question. A lot of times it's time and cost that's left out of the project management cycle, because usually, you can never meet the client's demands all the time because they usually want everything yesterday, and the process needs a lot of time. So I always think that time is a big thing. Hopefully I've kind of answered that. That's a big thing. Cost is going to be what cost is, but it's usually time. We're trying to meet to a certain deliverable to make sure that everybody gets their designs in that in time to make the construction cycle and that, but you also want to make sure that you do your homework up front so that you reduce the life cycle costs later on, when it gets into construction. When you're mobilizing more resources and more people, if the design has errors in it, it's going to cost you much greater at the construction levels, on the installation or the commissioning side. So a lot of times clients like to rush the engineering, but really it will help the life cycle costs if everything happens organically. I'd probably say that, to make sure that the quality processes are in place. So time is critical.
And David, it's funny because I feel like I've lived on both sides of the house, right? I started my career in engineering and I said, I need more time, I need more time. And now I'm sitting on the financial side of the house and I'm saying, you need less time, you need less time. So I 100% agree with that assessment there. The next question that I have is asking if you can shed some light, using some examples on situations where you may have had disagreements or different points of view with stakeholders and how you dealt with that.
That's a very good question because actually something that happens pretty often. I think it's important to have a conversation with the client in regards to knowing and understanding perspective. So one of the things I would say is sometimes, in as much as it's good to have a paper trail, email threads are not necessarily always the best means of getting through a disagreement. And in regards to where or what position you're sitting or standing at in regards to your opinion, making sure that you're backing it up with proof of specific tasks. So for example, if a client is or a stakeholder is asking for a requirement that is not suitable, it's our duty to make sure that we are able to advise them based off of the manual or technical reports that we've seen, to let them know that, hey, as much as you want to do this, these are the reasons why. So I think oftentimes the disagreement often comes from a place of misunderstanding on or different needs in terms of what needs to be met, and also in regards to the source of the information in regards as to why we're making these specific decisions. So in those cases, typically, there are cases where, sometimes we're not able to really agree in terms of this is what the client wants to do. And so we have to, at those times, escalate it to determine whether or not this is something we want to pursue. And so we can politely decline, or we can resolve it based off of, okay, this is what you want, but this is what we can do. And so come into a compromise. And then other times it's more so one way or the other, in the sense of, okay, even if we do accept what the stakeholder wants, we then have to put out disclaimers as to we've advised you that this is something that shouldn't be done, but in the event that you do want to do it, here are the factors that you do need to consider if you do proceed. And so those are some of the ways with which we, I guess, handle the different types of, disagreements or that we can have within the design process.
Yeah, I'll just kind of jump on that a little bit. So, a lot of the disagreements, like a lot of times our clients come to us because for the technical, and a lot of our disagreements unfortunately end up being more contractual, because we're trying to maintain, and you get into scope creep or other stuff, what they say is included and excluded. So we tried. We have a saying within Hatch here in our manifesto, acting like owners, and I've never met a stakeholder or client that has ever disagreed when you can talk like you're an owner, like it's your money that you're spending. And I honestly believe that with all our team. I always say we act like owners, that we don't want to, we want to make decisions that's best for the client, and we kind of handle things the best that we can in communication and collaboration, and working collaboratively with our clients and stakeholders to make sure that we understand the solution and that we deliver the best solution that can work for everybody within the constraints of the contract. I'll just say that.
Yeah, good point. And that's why any of those contracts people that are out there, I'm very picky about verbiage. I've had to learn that one too. Um, so this next
Yeah.
one I'm already giggling about, and Dave, I am going to pick on you just a little bit.
Okay.
How do you help those on teams that aren't engineers understand all of the nuances of engineering? So I guess, how do we turn our engineering speak into something that's consumable by the non-engineer?
Yeah, that's a very good point. That one is probably coming from one of my clients, actually, because we have these conversations all the time, and we have it because we deal a lot on a design builder or working directly with our clients. A lot of guys that are in managing positions have come up through construction backgrounds or other stuff, and not understanding, being pushing the engineer envelope, will say, of, hey, we just need you to sign this and seal this and whatever. And I have to, step back and say, well, we just can't do that. Our engineers design to a set of requirements. So we have to understand that, they can't just apply a seal or sign off on something that isn't in compliance with regulations. So we spend a lot of time trying to educate our stakeholders and clients and individuals within our team about what those requirements are and why. I think it's a better thing to have that conversation to explain the do's and don'ts of why engineering needs to be protected in this. Not only that, but if you're protecting the engineers individually, you're also protecting your company and the client itself. Like, and that's important to understand, that if you do something, everything's great until something happens out there and you find out that you haven't complied with something in the standards, right, and regulations. So I think,
Absolutely.
yeah.
And I think one other place where I always talk about having conversations with, engineering technical conversations with non-engineers, I think at a fundamental level, everybody understands stories and examples, right? So I think if you can make the conversation relatable to an instance that somebody experiences on a day-to-day basis, it's a lot easier to kind of get those concepts back into language that we're used to talking in lots of numbers and equations, and a lot of people don't appreciate that. So I
Yeah,
think finding some common grounds and exploring how we might be able to work through data in storytelling mode is a good skill set for any engineer.
that's right. And I guess it's the fine line also. Engineers are very linear thinkers. It's like, black or white. And when you're dealing with people in transportation and operations, let's just say that as an example, they're thinking about a whole different thing. So you have to be open to those ideas and the concepts that they have of moving traffic faster and more efficiently and trying to address their concerns within the engineering. So there's got to be some give and take there too, that you have to be a little bit willing to maybe get out your comfort zone a little bit to kind of blur the edges a little bit so it's not so linear.
All right, next question. Essay, we'll go back to you. What's your favorite part and least favorite part of being a signals engineer?
Ooh, that's a good question. I really love the team that I work with. I just have a great team, and it's not of an understatement. It's taught me the importance of being able to. There's just something about the design process that we do have with the teams that we have, and knowing that I have brilliant engineers that I get to work with and really pick their brains in regards to the design decisions that I'm making is really, really crucial. The work in itself is great. Like that, I would say those two things are kind of, I'll put them as one thing. My least favorite part about it, honestly, is coordinating. Coordinating can be a difficult thing. Like it doesn't seem like it should be, but coordinating with people can be challenging sometimes, especially when it's not so great news. So I think that's one of my difficult parts about it.
All right, Dave, I'm gonna throw that same question to you because I'd like to hear your perspective.
Okay, so I think probably, well, I've been doing this for a long time, and like I say to a lot of our young engineers coming up, that you have to want to go, go to work every day and do something that you're very passionate about. And it was probably something, in my younger years that I tried out a bunch of different things. And, I've done everything from, pounded spikes and built switches in the trackside in my career. And after a couple of years, I said, I can do better than this. And I went back to school and I got some education. And then I joined another railroad and started, climbing poles. They didn't have a job for me at that time. And then somebody realized, oh, geez, this guy's got a tech diploma, and decided to bring me into the design office. And honestly, I've been passionate ever since about designing and creating a new and doing something that I think has a benefit to lots of people. And that's what I think, if you're passionate about it, you don't mind coming to work every day. And as Essay said, working with all the people, that's the best for me, right? Collaborating with people and working together to deliver a common goal in the end, whether that's big major projects. You just feel something good, and being in detailed design allows us to take stuff from concept all the way to as installed, normally. And there's nothing more rewarding than that, to actually seeing something that you've been involved with get to the end. What's least, well, obviously it's changed over the years. Obviously, I'm in a management role, and you've always run into things that have limited you from being successful. And sometimes it might be just multitasking too much, and you feel like you're not able to accomplish everything. So I would probably say, if you're spread too thin doing stuff with management and design and trying to keep everybody moving forward, maybe the multitasking is probably my least favorite thing about everything, because sometimes you set your bars pretty high for yourself and your goals, and sometimes you feel like you're not achieving that if you're spread too thin. Okay, I think that would be my answer.
All right. Well, both great answers. And it's interesting probably why you guys make such a great team, because I heard the coordinating may be a problem on one side and the coordinating is a benefit on the other side. So there you go. It's probably why you guys are pretty successful. I think we have time for one last question. And Essay, I think I'm going to give this one to you. We have a listener that is not technical, and she's wanting a little bit of advice for how a non-technical female in the industry can really start to showcase the value they can bring without that technical background.
Ooh, that's a loaded question.
Well, I'm sure that you work with, like we said in the first question, right? You're working
Yes.
with lots of different individuals, and so what do you see as some of the values that some of the non-engineers that you work with, and those particularly females in the industry, how do you see value in them?
Um, I'd say knowing your strengths is key because in as much like so the design or the technical part that I say someone like myself can focus on is one specific piece to the whole part of the puzzle. Um, so being able to focus on your strengths and knowing how you add value to the projects. So for example, if you're great with project management and coordinating, that's where you shine. In regards to the technical terms, I think it's important to have means through which you can get accustomed to what they are. Maybe not necessarily all the specifics, but being able to be exposed to the high level definitions of what things can be could be helpful in being able to be aware of certain conversations that you have because being a non-technical person in a technical space can be challenging. And so, especially even in meetings, even myself, like when I'm in meetings where it's multidisciplinary, there's so many things that other people, other disciplines could be speaking about that I have no idea. And so sometimes I think having a great network and making those connections and having people that you can ask questions about specific topics and learn more. I think being open to learning will be my first thing, and the second part of it would be, which is really the first, is focusing on your strengths and being comfortable in what you're good at and excelling there.
I think those are all great things, and I would just add on just a little bit to the be willing to ask questions, right?
Yes.
I think, coming up and being brave in those environments and making sure it's better to ask the question if you don't know than to assume and make the wrong decision. So be brave, even if it means pulling somebody aside after a meeting to say, hey, what were you really talking about there? I think that that's a really good first step. But I also, I'm happy to see that the listener is actually on this call because this series is actually really aimed at providing technical concepts and language in a consumable format for that non-technical person. So I would say go study up on the LRW website. There's a lot of material out there. This is our 7th session, and I think just educating yourself on the verbiage and terminology and being brave and asking those questions is the best way to really exhibit that value that you already are bringing. All right, well, I think that brings us to the end of our webinar. Thank you guys both so much for the great material and discussion. Listeners, we appreciate you joining. Like I said, this one is actually recorded, so if you are a member, you can access it via the member portal probably in about a week. After that, if you are interested in getting it and you're non-member, look at those membership options, either the individual membership or the corporate partnership. But thanks again, everybody. I hope you have a great afternoon and a great end to your week, and we'll be talking to y'all soon.
Thanks, everyone.
Bye.